Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue with fluid mechanics, in that the first chapter, properties of fluids, and in this the part 3, which is quantification of viscosity for different liquids and gases. Now let us have a quick recap of whatever we have done in the last classes. We had seen what is a flow, we had seen what is a fluid, we have seen what is Newton's law of viscosity, and we have mathematically modeled it. Mathematical statement for the Newton's law of viscosity is shear stress is equal to mu, which is the coefficient of viscosity, into d gamma by dt, which is rate of shear strain, and rate of shear strain is also equal to velocity gradient at that point. So next we will go with unit of viscosity. Unit of viscosity in SI units can be derived like this. Okay, so from the Newton's law of viscosity we get mu is equal to tau by d gamma by dt. Now d gamma by dt we can say in terms of 1 by s, and tau is in terms of pascals. So unit of viscosity is Pascal seconds. Now there is a joke that in case you are in a quiz, you are participating in a quiz, and the question you are getting is what is the unit of viscosity, and in fact you don't know the unit of viscosity, then you say generally in quiz pass. So if you say pass because you do not know, the quiz master will say it is the right answer. So the viscosity of the unit of viscosity is PAS, which is pass. So jokes apart, so we will see what is pass. Pass, PAS, Pascal second, can also be written as Newton per meter square into second. Newton, you know, from Newton's law of viscosity, kg meter per second square, mass into acceleration. Now when we simplify it, we get kg per meter second. This can also be written as a dimensional formula, mass, length inverse, time inverse. Okay, in CGS unit, see what happens is, generally in our industries, people are reluctant to change to SI units. So some of the units have remained what it was previously. And one of the units which has not changed much is unit of viscosity. Even today, people use CGS unit, and CGS unit is poise. And one poise is 1 gram per centimeter second. Now 1 gram per centimeter second and PAS, what is the relation? 1 PAS, Pascal second, is 1 kg meter per second. 1 kg is 1000 gram, 1 meter is 100 centimeter. So what we get is 1 PAS is equal to 1000 by 100, which is 10 grams per centimeter second, which is poise. So 1 PAS is equal to 10 poise. Now let us see the viscosity of some of the commonly occurring fluids. When we say fluids, fluids can be gases or liquids. Now gases and liquids, the viscosity varies by a great amount. So we will see all these things. Initially we will see viscosity of liquids. Now in case of liquids, liquids are generally represented, or their viscosity is measured in terms of millipascal second. Now 1 millipascal second is actually equal to 1 centipoise. Now water, it is 0.89 centipoise or millipascal second. Compared to that, ethanol has more viscosity. Mercury, although it has more density, viscosity is almost comparable. So this shows that density and viscosity are two different properties, and the one which is denser may have comparable property. Now let us see some of the things which is less denser than water, which is coconut oil, which is much more viscous than water. Okay, so castor oil also similar way has very high viscosity, 650 centipoise or millipascal second. Glycerine 950, kerosene 1.94, blood, the viscosity doesn't remain same, it varies according to the shear strain, which is rate of shear strain which is put on it. So we will see that later when we see what are the different types of fluids based on viscosity. Honey also varies from 2000 to 10,000. Milk 2 to 4. Aluminium, the molten aluminium, is of the order of 1.24. Iron 5.22, that is above 1000, above its melting point. Upper mantle of the earth is very viscous. It is 7 into 10 power 20. Okay. So now what we can see is this gives us an idea of what are the different viscosities, and that will help us in whatever we do. Now next we will see about gases. Gas viscosity is measured in terms of micropascal second. Okay. So now air has a viscosity of 18.46, methane 11.13, nitrogen 17.6, oxygen 20.64. Now you can see air, the viscosity is in between nitrogen and oxygen. Air can be seen as a mixture of nitrogen and oxygen, and the viscosity of air is in between that. Okay. Steam is 12.49, carbon monoxide is 17.5, carbon dioxide is 14.9, helium is 19.85, hydrogen is 8.9. Now here all these viscosities these viscosity vary with the temperature. Okay, but here we have represented this viscosity for getting an idea of how the viscosity of different fluids compare. Okay, now in the next lecture we will see how the viscosity varies with temperature for liquids as well as gases. Now we'll summarize whatever we have done. Unit of viscosity in SI units is PAS, Pascal second, and CGS, it is poise. 1 pas is equal to 10 poise. Viscosity of liquids are generally measured in terms of micropascal second or centipoise. Viscosity of gases are measured in case of micropascal second, in terms of micropascal second. Viscosity has no relation with the density of the fluid. Thank you very much. I hope you have learned something from this video. Subscribe for more videos, as well as click the bell icon. We are continuing with fluid mechanics. We will complete fluid mechanics as a whole. Okay, so this will help you to understand or have a course of whole fluid mechanics through YouTube. Thank you very much.